see if we're streaming. Live stream. Are we streaming? I have no idea if we're streaming or not. I think I am. Okay, let's see. I think I am live streaming. What am I supposed to say? I have a chat here that says, say something. Oh, I have 2 people watching. It's like a weird echo. Let me know if you're in the audience if you hear that echo. I have no idea what problems we're going to do though. Let me know if you're in the audience if you hear that echo. I have no idea what problems we're going to do though. Now I have 3 people watching, but nobody's asked a question yet. Oh, I think that's really loud. Now I have 3 people watching, but nobody's asked a question yet. The sound is like all warbly on this thing. See, because the problem's going to be on the chat is I have to do problems. And then if I hold it up, ooh, see, I have to like, Up, somebody left my chat. They didn't ask any questions. If the chat won't work, you can always kick me at, hold on, oh wait, see, you don't see this, but I gotta move this screen here. You can always chat me at, whoa, how's this work? Mrs. _Falk _IRMS. You can kick me with your questions on my phone. Ah, wait, what did I do here? We're back to 3 people now watching. You guys got to ask a question. Ooh, there's a setting here to automatically block bad words in the chat. Okay, but nobody's chatting me. I'm just like pressing buttons on my screen here. Can't see what I'm doing here. And there's still nothing. Oh, now we have 4 people watching. 4 people have signed on. Nobody's asking a question. Oh, now we have 4 people watching. 4 people have signed on. Nobody's asking a question. I'm just sitting here, watching myself. Still just watching myself. Oh, my brother just texted me. He sees me. So one of my 5 viewers is my brother. Hi. Scott. What? He says it's blurry. I know it's blurry. Oh, he wants to know how he chats with me. I think you type in the chat box, maybe? I've never done this before. My students asked me to try it out, but no one is asking questions. And we lost 2 viewers. And now my brother says there's also a weird noise. I know, school board equipment sucks. I mean, but actually this isn't even school board equipment. I probably wasn't supposed to say it. My school board computer won't even allow me to stream. I know, school board equipment sucks. I mean, but actually this isn't even school board equipment. I probably wasn't supposed to say it. My school board computer won't even allow me to stream. He says, I think it's a delay. No, I hear the delay. But here, Scott, we'll do a problem for you. So we're going to do problem number 5. Because, whoops, I'm dropping my stuff. We're going to do something. That's a text of the night. My husband just texted me. He says he's going to go buy me a new computer right now because he can't stand my complaining. No, it's okay. Okay, so we're going to do a problem. We are going to, oh, everybody's, this is interesting. Okay, so we're going to do a problem. I have a circle. I'll draw this for you guys. I have a circle. I'm going to go to this screen so you can see what I'm doing. And it tells me that the central angle measures 72 degrees. And the radius is 7. This is a problem on our test. So if I wanted to find the area of this sector, I would set this up as a proportion. And the proportion would be the measure of this central angle, which is 72. I'm going to scoot over this way. Over 360 because there's 360 degrees in a triangle, is going to equal the area of the sector over the total amount, the total area of the triangle, of the circle. And you're going to find the total area of the circle by multiplying 7 times 7, which is 49, times pi, because your area is pi radius squared. I don't know how you can see this. So using my off-screen calculator here, 7 squared was 49 times 3.14 means the area is 153.86. We're now going to cross multiply. 360 times x is 360x. So we're cross multiplying. And then 153.86 times 72 is 11,083.54. And then, this would work better if I had a big whiteboard behind me. And then 11,083.54 divided by 360 would make x equal to 30.79. I still only have 4 people watching. And nobody's watching. So Scott, did you see that problem? Let's ask him. So Scott, did you see that problem? We're just waiting if anybody's out there. I feel like Mr. Tom. Was it Agent Tom, whatever that guy is in the capsule floating off the space? You know that song? There's 4 people watching. But are they going to actually ask anything? Doo-dee-doo-dee-doo. And just, there's a delay, so I watch myself make silly faces and then I see it again, because I have 2 different screens. And now even my brother is not responding any longer. Maybe somebody brought him some food. Roth can see me. Yay! Natalie, do you have a question? Natalie's going to save me from embarrassment. Oh, yay! Emily's asking for number 2. So. Okay, so let's see if you can see the screen. I gotta like get this so you can see the screen. So, for number 2, let me draw the picture. Basically, the problem looks like this, and you have a track, and you are running around the track. The entire length of the track is 106 feet. Okay, so like that. Okay, and then it has these 2 semicircles at the end that each have a diameter of 12. Okay, so when you're running around the track, the part that you run here and here is not part of the 106. So if the diameter of the circles is 12, this distance here is 6 feet because it's the radius on each side. So this middle part, this is hard to do to figure out where my hands are, but in this middle part, in this section here, I'll try and hold it like that. Okay, is going to be 106 minus 6 minus 6. So 106 minus 12 is 94 feet. Okay, and then this 94 feet, you're going to run it down here, and you're going to run up here. So you're going to run 2 basic straightaways. 94 plus 94 is 188. And then you want to find this curved part. There's 2 semicircles. They're going to make a whole circle. So when you run, you're running the circumference. Circumference is like the perimeter. So 6 of a radius and 6 of a radius is 12 of a diameter. This is 12 times pi. If you were solving this problem, move that up a little bit so you can see a little bit better. If you were solving this problem for actual distance, you would use an approximation for pi, like 3.14, and multiply it by 12 and add it to 188. But the problem doesn't want you to do that. They want it in terms of pi. So you're going to run the straightaways of 188, the curves of 12 pi, and in simplest radical form, you cannot add those together because they're not like terms. This is just a number, and this is a number with pi. So your answer actually is 188 plus 12 pi. So the question is, Emily, did that help you? Okay, so we did our first question that was asked by somebody. Yay, Emily. Ooh, Natalie is asking for number 16, and there's Scott Zimbler. He is confused by all math. It's okay, Scott. We can help you here. So problem number 16. So I have to look at problem number 16. So problem number 16 involves a satellite, and it's made up of a cylinder and 2 hemispheres. So first I'm going to draw the really bad, inappropriate school drawing that has made everybody laugh. That is what you have. You have, scoot this over, a cylinder and two halves, two hemispheres. If I put them together, I would get a total sphere. I might blur you out for a second because for some reason right now it tells me that a warning on my computer about the signal. So back to this problem. I'm going to need the formula for the volume of a cylinder, and I'm going to need the formula for the volume of a sphere, because the two hemispheres will make one sphere and put it together. So I'm going to erase my very bad drawing, and I'm going to write the formulas. For a sphere, the volume is 4/3 pi radius cubed. And for a cylinder, the volume is pi radius squared times the height. Because in the cylinder, we're finding the area of the base. It's a circular base, so radius squared times pi, that's the area of the base, times the height. Now we can plug in these numbers. So on the sphere, let's see here what they have here. Okay, the radius on these, they don't give us a radius, but they give us a diameter of 9. So that means the radius is 4.5. So I'm going to fill in these numbers here. And pi 4.5 squared. And the height on the cylinder was 19. So I'm going to hold this up now. This is how you would set these up. 4/3 pi 4.5 to the third for the sphere, and the cylinder pi times 4.5 squared times 19. So I'm going to take this away. I'm going to fill in these numbers. So the first thing I'm going to do is the 4.5 to the third. So taking my calculator here, I'm going to do 4.5 times 4.5 times 4.5. And that's going to equal 91, I don't know if you can see that, 0.125. Then I'm going to take that 91.125, I'm going to multiply it by 4. I get 364.5, and then divide by 3. So I get 121.5, but remember, I still have the pi. So the volume of the sphere is 121.5 pi, because they said leave it in terms of pi. Now for the cylinder, I'm going to do the 4.5 times 4.5, and that's 20.25 times 19, and that's 384.75. 384.75. Remember, I didn't multiply by 3.14 or the pi button because they said leave it in terms of pi. So now I'm going to add those two together. I'm going to add the volume of the sphere, 121.5 pi, and the volume of the cylinder, 384.75 pi. I'm going to add those two together, and I get 506.25 pi. Oh, and I got another question. Yay! And when I finish 16, can I do number 6? Yes, I can. Oh, we got 6 people watching now. That's very exciting. Okay. So problem number 6. Oh, this is a doozy. So I have a circle. I have a sector, 30, 60-degree angle, and that's shaded. So that's what I have here. You should have it in front of you. Okay? So first I need to find the area of the sector. The area of the sector isn't bad. The central angle is 60. So 60 out of 360 is going to equal the area of the sector over the area of the circle. And they asked me to leave this in terms of pi. So the radius squared, 30 times 30 is 900 times pi, means the area is 900 pi. Now I'm going to cross multiply. 360 times x is 360x. Fix my chair a little bit, move my computer. Okay? And then 900 times 60 is 54,000. Okay? And it's actually 54,000 pi. So now I'm going to divide the 54,000 pi by 360. Okay? So I'm going to take the 360 from here and go over here. And in the calculator, when I do 54,000 divided by 360, I'm going to get 150. And remember, I still have my pi because I'm leaving this in terms of pi. So the area of this sector is 150 pi. Now, though, I need to find the area of this triangle because I'm going to subtract it so that all I have left is this little bit of shaded area here. And in order to do that, I need to do trigonometry. So I have a triangle that has a 60-degree angle on top. Actually, all three would be 60, then it's equilateral, and a side length of 30 degrees. I don't know how to find missing lengths and measurements unless it's a right triangle. So I'm going to draw an altitude here to create two right triangles. But when I do that, that altitude also acts as an angle bisector. So instead of 60 degrees, I have a 30-degree angle, 30-degree angle. So I'm only going to use half of this. Now, do not get confused. It's just coincidence that this side length is 30, okay? Maybe that's 30 inches or 30 centimeters or whatever. And this angle is 30 degrees, but it's a 30, 60, 90. So that's 90 degrees and that's 60 degrees. I have to remember my rules for 30, 60, 90-degree triangle. And hopefully you remember that what I'm going to call the side opposite the 30-degree angle x. So that way the 60 is x radical 3 and the 90 is 2x. This 30 is the length opposite the hypotenuse of 90. Okay? So that's 2x. If 2x equals 30, x equals 15, and that's the side opposite the 30 degree. That also then means that this height is opposite the 60-degree angle, and that's x times radical 3. So that becomes 15 radical 3. So I have those dimensions to find the area of a triangle. It's 1/2 of the base times the height. I could multiply the base times the height and divide by 2, but remember that this 15 isn't the base of the whole triangle. 30 is. Or I could just multiply this half of the base, because I already have it in half, times the height of the triangle. So that's what I'm going to do, meaning I'm going to multiply this 15 times this 15 radical 3. So when I do that, I multiply the whole numbers first. 15 times 15 is 225 times radical 3, which would just be 225 radical 3. So I want to take the entire area of the sector, which is 150 pi, and from that I want to subtract 225 radical 3. I'm going to get rid of this line here. It looks like a minus sign. But I cannot subtract 225 radical 3 from 150 pi because they're not like terms. This is a number with a pi. This is a number with an irrational, with a radical sign, with an irrational. So my final answer is just that. 150 pi minus 225 radical 3. And that's the final answer. Oh, yay! Now I have another one. I have Mercy in the loop asking for problem number 11. This is so exciting. I love you guys. So for problem number 11, you guys are picking the really difficult ones tonight, but I guess that's good. That means that hopefully the easier ones you're getting. So for number 11, this is the one where we're finding the area of the, let me do this. Why don't I try this way? Well, that might be easier. So we're finding the area of a hexagon. And the hexagon is made up of triangles. The height of the triangle is 2, and the length of the sides of the hexagon are 4 radical 3 over 3. Okay? So I actually want to multiply 2 times 4 radical 3 over 3 and then divide by a half. But if I wanted to, I could take either of these terms and divide by a half first. Well, I found in class that sometimes my kids were confused about how to divide 4 radical 3 divided by 3. Okay? So, divided over 3, divided it in half. They were confused about that. But you should know how to divide 2 in half. 2 divided by 2 is 1. So, 1/2 of 2 is 1. 1/2 of 2 is 1. So I'm going to take that 1. I'm going to multiply it by 4 radical 3 over 3. 1 times anything, it leaves it by itself. So I have 4 radical 3 over 3. That's the area of the triangle. So since it's a regular hexagon, that means it has 6 sides. There's 6 triangles. So I'm going to multiply by 6. That's like multiplying by 6 over 1. 6 times 4 is 24. Okay, then we just have the radical 3 because there's no radical next to the 6. And 3 times 1 because 6 is like 6 over 1. So 4 radical 3 over 3 times 6 is 24 radical 3 over 3. 24 and 3 are both divisible by 1. Now, I always keep saying that. 24 and 3 are both divisible by 3. 3 divided by 3 is 1. And 24 divided by 3 is 8. So 8 radical 3 over 1. So your final answer is 8 radical 3. Now we have 7 people watching. Let's see if we have questions. Okay, right now we have no more questions. I'm going to give it a few minutes to see if I have a question. Otherwise, I said I would do this for about a half an hour. I will try doing it over the weekend also and tell you in class tomorrow when I'm doing it. Next time I should have some water with me. Anybody else want to sign in and say that they were actually watching? I got 7 people watching. Maybe I should give extra credit if you... Sorry, I'm laughing. So my husband just texted me. I took the pies out of the oven, but they are square. Ba-dum-bump. He's trying to watch a baseball game, and I'm sitting in the office in our house, and I'm sure he can hear everything that I'm saying. Very funny. Just seeing if anybody's kicking me. Nobody's kicking me. See if anybody's emailing me. No. Okay, let's see. Nothing else? Nothing else? Oh, Emily posted. Can you do number 8? Okay, Em. Oh, that was the one I was thinking of like the square pies. I have a circle with a square inscribed in the circle. Okay? So I want you to get that this central angle is 90. The reason you would get that is you could create 4 angles here. So 360 divided by 4 is 90. Now my dad is texting in what you're talking about. Dad, you know how to do this stuff. Not even talking to him. So 360 divided by 4 is 90. This is 90 degrees. Remember, these were 90 degrees because it's a square. So if this is 90, and these are obviously going to be congruent, these angles are congruent, you should recognize this is a 45, 45, 90 triangle, which means the sides opposite the 45-degree angles are x. And the side opposite the 90 is x radical 2. This, which is labeled in this one here is what's labeled in your review as 3 radical 2. This is a side across from the 45. This is a side across from the 90. So I'm going to take the side across from the 45, 3 radical 2, and I'm going to multiply it by radical 2. Radical 2 times radical 2 is radical 4. Right? And 3 times radical 4, which is the square root of 4, that's 2. So now I have 3 times 2. 3 times 2 is 6. So this side length is 6. Okay? Now, correct. When we had a regular octagon or pentagon or whatever, we broke these triangles up and we multiplied by how many were there. But in this case, rather than finding a height of this and finding the area of this triangle and multiplying by 4, since it's a square, that means both the height and the length are going to be equal. So if this is 6 and this is 6, 6 times 6 is 36. And the area of the square is 36. Let's see whose we have now. Ooh, both Emily and Natalie wanted number 8. That was number 8. And we even got a por favor out of Natalie. Natalie and Emily, I know, would really love it if I did the area of the volume of the cylinder with 2 different radii, but I'm not going to do that right now. Let's ask Shelley, that's my father, if he has a math question. Ooh, now we got 6 watching. This is so fun. Okay, we got Natalie's number 8. Oh, wait. Shelley Zimbler is texting back. Ooh, my highlight was 8 viewers at 8:11. Ooh, I had 8 viewers at 8:16 and 8 viewers at 8:21. Oh, we're on a roll, Em. 9 and 10. Just trying to figure out how to get online with YouTube. Go to YouTube. Search Stefanie Falk. Okay, so let's go to 9 and 10. Okay. Now, that same idea, we're going to find the area of a regular octagon. So in order to do that, we have a triangle. We actually would have 8 congruent triangles in a regular octagon. And I'm told that the side length on this regular octagon is 9. Okay? Once again, I can deal with right triangles with trigonometry. So I'm going to draw an altitude. Now, if I had a regular octagon, there would be 8 triangles that would all meet in a point. So since there's 360 degrees around a circle, 360 divided by 8 is 45. So this central angle is 45 degrees. When I create this altitude, I also create an angle bisector. It's the same thing. So it's 22.5 degrees. I'm going to need to find, oh, I said side length of 9 here. Ooh, I messed up. Side length of 9. This is 9. Okay? So when I break this in half, because this altitude is an angle bisector, it's also a perpendicular bisector, this is going to be 4.5, this is going to be 4.5. I'm only going to deal with this right triangle right here. So I need to find the measurement for the base, which I have, and for the height. The height here is also going to be the adjacent, I'm trying to get comfortable here, the adjacent side to my 22.5 degree angle. So if I have opposite and adjacent, I'm dealing with tangent, the TOA part of SOHCAHTOA. So the tangent of 22.5 equals the opposite, which is 4.5, over the adjacent. I'm going to use A. That's what I'm trying to find. So if I have a scientific calculator, that times that is going to be that, which also means that this divided by this equals this. So in my scientific calculator, I want to do, I have to get to my scientific calculator. 4.5 divided by 22.5 tan equals. Now I say 22.5 and then tan because most scientific calculators require you to put in the angle degree and then tangent. So when I do all of that, I get that the height is 10.8639, etc., etc. So I had a lot of confusion in class. So rather than, I'm just going to put a bunch of decimals there, 10.86396. Now, to find the area of this, 1/2 of the base times the height. I could do base times height divided by 2, but then I have to take this 4.5, remember that it's 9, multiply it by the height, and then divide by 2. So instead, I'm going to just do the 10.8936. If you kept all of this in the calculator, you don't have to retype it, but I didn't, times 4.5 equals 49. See, I hit something wrong. I hate when I do this. What did I say it was? 10.86396 times 4.5 equals 48.887. Now, this is slightly rounded error, so I'm going to go back to what I had before. If I do 4.5 divided by 22.5 tangent, I get this whole, can you see it there? This whole long number. I want the whole long number. Now I want to multiply that by 1/2 of the base, which is 4.5, and I get 48.887. 0.8878, blah, 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 blah. Then, because the original problem dealt with an octagon, there were 8 of these triangles, I want to multiply by 8, and I get, this one says 36. I think when we did it in class, it was actually 36.1. I am not going to be that critical of rounding errors when you do it in class. But it's not 36. 48.87, I'm all messed up here, times 6 is, what? Times 8. I can't even think any longer. 48.88 times 8 is 391.04. Sorry about those technical difficulties. Well, not really technical difficulties. I just messed up. But it's 8:42 at night, and I'm in my pajamas, and I've taken my shower. I'm ready for bed, but I'm helping you all with math. So it is what it is. Let me see what else we needed here. Well, we now have 12 viewers. Oh, Leroy's here. So is Naomi Zimbler. Who is Willis? Oh my God, Leroy, that's what I'm going to call you. I'm going to call you Willis. Go watch Different Strokes. Man, oh man, oh man. Okay. M also wanted number 10. So number 10 is like number 8. And I think number 10 is going to be the last one we're going to do for tonight, and then we'll do more over the weekend. But for number 10, find the area of a decagon with a radius of 7. Okay, this is the more complicated problem. It's a decagon. Radius of 7 means the slant height is 7. If it's a decagon, there's 10 central angles. 360 divided by 10 is 36. And when I split this in half, this becomes 18. Because this height, this altitude, is also an angle bisector divided in half. It's also a perpendicular bisector. So I first need to find this side. That's x. That's the opposite side, and since this is a 90-degree triangle, I have the hypotenuse. When I have opposite and hypotenuse, I'm using sine. So the sine of 18 equals the opposite over the hypotenuse. So in this case, I'm actually going to do, in my calculator, 18 sine times 7, and that gives me 2.16. Now I want to find this, which is the adjacent side. When I have adjacent over hypotenuse, then I'm using the cosine. So the cosine of 18. So in my into my calculator, 18 cosine times 7 equals 6.65. So the height here is 6.65. So once again, to find the area of the triangle, 1/2 of the base, which is 2.16, the entire base would be this much. So half of this is 2.16 times 6.65 equals 14.364. Okay? And then, let me just double check that because I just don't feel like that's right, but it should be. 2.16 times 6.65 is 14.364. It's a decagon, so there's 10 of them. So the answer is 143.64, but it says round to the 10th, so 143.6. Let's see if there's any easy questions that anybody asked. Okay, so we have all kinds of questions here. What are the weekend times? Are you doing this on the weekend? I will do this on the weekend. I don't know the weekend times yet. I have to look at my schedule. But this has been an enthralling 50 minutes and 19 seconds with you all, and I'm tired. So I will see you all hopefully tomorrow. Remember, you have USA test prep to do tomorrow. Make sure you do it. When you do it, it tells you whether you're right or wrong, and if you're wrong, how to do it. Write that down because you might get a later problem that you just plug the same answers in. So we hit, I think tonight our highlight was 12. Let's see. Oh, wait. Let's see, was the highlight top 12? Yep. At 8:41, we had 12 viewers. So thank you so much for your time, and I'm signing off.